Today's topic is law of cosines. It's really one formula, but you'll see it in three different basic forms and then three alternate forms that I'll show you. But you should realize that the three basic forms of this are actually really all the same thing. So the very first one, we'll go and just take a look at what these look like. When you're given a triangle in this nature, it doesn't have to be a right triangle. I know a lot of problems in high school tend to deal with that. A lot of basic geometry deals with right triangles. Here, notice we have an obtuse triangle. This would work if it was an acute triangle, a right triangle, whatever you want. You'll see this basic formula most of the time. You'll see a squared equals b squared plus c squared minus 2bc cosine of big A, where little a is the side length A that corresponds with big A, which is the angle A on the other side. Now I will make a little side note as we move forward that I've put a little hat, a little bar over my big C here just because there are times when I'm writing this that I feel like my little c and big C could be a little indistinguishable. So I want to make sure it's clear which one's which. So if you see a little bar over it, I'm using that just to show that that's my angle here. The reason I say that there are three formulas that are really all one formula is if I don't want this to be a squared, if I'd rather it be b or c squared, then I can do that. We'll have two alternate forms, and these are very easy to put together from here because with this, I can go in and say, well, look, this was b squared and c squared with the a squared out here. So instead of b squared, we'll have the a squared here, and we'll just leave c squared where it's at. And then instead of negative 2bc, notice here b and c were paired together. I'll pair a and c together for this one. And then the way we know which angle goes in the set of parentheses is that from the very beginning here, we had little a and big A paired up. So we're going to pair little b with big B. And so likewise, you'll be able to go in and say, okay, this one has c squared, so this must be a squared plus b squared minus 2ab cosine of c. So in terms of memorization, there's not a lot of work here because you only need to know the general format, the general idea behind it. You know that this little one pairs with the angle, and then you know that whatever two things are being added and squared pair up with the two numbers that are being multiplied here. So b and c, a and c pair with a and c, a and b pair with a and b. In general, these forms, by the way, are most useful to find side lengths. So I'll make a little note here. The idea being that if you know two sides, notice those are the same, if you know two sides and the angle between them, so if I look at B and C, notice that the included angle between them, the angle that B and C make is angle A. So if this angle doesn't match the two sides you're given, then you can solve for A, because I could plug in BC, BC, and big A, and I'd be able to go in and solve for little a. I'd have to take a square root of both sides. I'd have to peel a square off of each side, and that's something you'll see in an example video later, but it's nothing too crazy. The only thing that can be a little weird is if you need to solve for an angle. So what we're going to do is just make a quick note here that we can rearrange this to solve for that angle A up here. So let's do that real fast. We'll take a squared equals b squared plus c squared minus 2bc times cosine of a. And we're going to go in and just real fast show you what that would look like to solve for angle A. First of all, we have all the stuff being added on the front, so we're going to subtract that from both sides. So here we are, we've subtracted b squared and we subtracted c squared from both sides of our equation. And we're going to follow that by dividing by the numbers in the front here, the negative 2bc. So we have a squared minus b squared minus c squared all over negative 2bc, which will now be equal to cosine of big A. If you're comfortable with using trigonometry to solve problems, hopefully you'll realize then that we can take the inverse cosine of both sides here. The way you get rid of cosine, or rather the way to find the angle that's hiding inside of cosine, is by using the inverse cosine of the other side. And I'm going to write this formally as the measure of angle A here, just to be a little bit more mathematically sound. This right here doesn't look amazing. I'll acknowledge that. But what I will also acknowledge is that if I'm given A, B, and C, all the little variables, all the side lengths, it is very straightforward to just plug it right into these here and you're done. The calculator will do all the work for you. That's how you find a measure of an angle. In fact, notice again that there's a pairing of side lengths that you can work with here, or sides and angles. We see little a and big A again, and then we see little b, little c paired up with little b and little c. It's a pattern. Little a comes first if big A is the angle you're looking for, so little b should come first if you're looking for big B. And then from there, you just fill in with the remaining variables. We don't really have a choice. If you'll rearrange your other equations, you'll see that this would be a true statement, as well as the following equation here. So again, notice that to find big C, remember I'm going to jot that down with this little hat here. Maybe I should have done that up here as well, just to be thorough. Angle C pairs with little c, and then A and B take over the remaining roles. These right here, very clearly, I've already established this, would be useful for finding angles. So, notice that all three of these look exactly the same in terms of the general structure. Just like the previous three iterations, little a and big A pair up, little b and big B, little c and big C. That's how you can kind of keep up with everything else. The rest of it just maintains this one structure. And the way we're going to look at this, you can find your angles if you're given all three sides. If you know all three side lengths, you can find the angles inside your triangle. It does not matter if it's a right triangle, an acute triangle, an obtuse triangle, it won't matter. So back up here, to find your side lengths, you can do this if you're given two sides and their included angle. Now, just as a reminder, if you want their included angle, this would be something of this nature, where you have two sides that are adjacent to each other, and you have this angle here that's right between them. So in our diagram above, for example, we saw little c and little b paired up with big A, because this was the angle that was included between them, the angle that they make. So if you're given these three adjacent pieces of information, you would be able to use the original formula to try to find one of the side lengths. And the nice thing is, with law of cosines, if you were given this information, and then you went in and you found the length of little a, well, once you know little a, you now know all three sides, so you can come down here and find the rest of the angles. So you could solve the whole triangle using law of cosines, as long as you had three pieces of information that fit one of these two patterns. If you have all three sides, or you have a side angle side situation. So the last thing I'll make a note of then is, if you're familiar from other courses of geometry, these would be triangles that are situated as side angle side or side 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 based on given information.